Hello students. So now we are going to start second topic of the organic chemistry, catenation power of carbon. What is the unique properties of carbon in organic chemistry? We already discussed first class the introduction of organic chemistry, what is organic chemistry, what is inorganic chemistry. So organic chemistry means those compounds contain carbon, hydrogen, it means hydrocarbon and their derivatives. So organic chemistry is the chemistry of carbon compounds with hydrogen and other element, maybe oxygen, nitrogen, sulfur, halogen, phosphorus. So, now in continuation of the chapter 12, some basic principle and techniques. So we are going to start second class. Now, characters of characteristic properties of carbon. So why carbon form the long chain? Let's see. First point. Tetravalency of carbon. We already learned that valency of carbon is 4. 6 atomic number, 1s2, 2s2 and 2p2. So what is the valency? 2 and 2. 4 valence electron present here. So, for complete its octet, it needed कितने इलेक्ट्रॉन की आवश्यकता है इसे? It needed 4 electrons. If it shared with 4 electron, it achieved the 8 electrons. And if it donates 4 electron, if it accept 4 electron, यदि ये 4 इलेक्ट्रॉन डोनेट करता है तो इस पर चार्ज होगा 4 प्लस. अगर ये 4 इलेक्ट्रॉन एक्सेप्ट करता है तो इस पर चार्ज होगा 4 माइनस, विच इज नॉट पॉसिबल. इट कांट अकोमोडेट 4 इलेक्ट्रॉन. देयर इज नो वैकेंट डी ऑर्बिटल. यहाँ कोई वैकेंट डी ऑर्बिटल नहीं है. 2d इज नॉट पॉसिबल. सो देयर इज नो वैकेंट डी ऑर्बिटल. तो कार्बन अपने वैलेंसी को एक्सपेंड नहीं कर सकता बिकॉज देयर इज नो डी ऑर्बिटल, नो वैकेंट डी ऑर्बिटल and 4 plus charge, and this high charge density can't handled by the carbon. For this, high ionization energy and high electron gain enthalpy which is not possible. So C4 plus and C4 minus, it means not accommodate by the carbon. कार्बन में 4 प्लस नहीं हो सकता, 4 माइनस नहीं हो सकता. इट मीन्स कार्बन इज फ्रेंडली. Carbon only shared it 4 electrons and achieved the octet 8 electron and get stable by sharing. So carbon is tetracovalent. It means carbon is called the tetracovalent and this bond is called the covalent bond. Carbon always form covalent bond because of sharing of 4 electrons. So it's clear. What is the characteristic properties of carbon? First, tetravalency of the carbon. Carbon form the 4 bond by sharing of its electron. When electrons are shared, they form the covalent bond. Covalent bond present between two non-metal, two same non-metal generally which have low electronegativity difference. They form the covalent bond. CC bond is covalent bond. CH bond is also covalent bond. So these are covalent bond. So carbon, so keeping in mind always that carbon form 4 bond. Clear? Now let's see. One scientist, who find out the structure of methane. and carbon is tetrahedron structure. The structure of carbon is tetrahedron structure. This is the carbon, and bond angle between two carbon is 109 degree 28 dash, and this tetrahedron structure, tetrahedron, one carbon between 1 2 3 4, there is 4 bond. This structure is tetrahedron, and this structure find out by the Van 't and Liebel, by Liebel, Van 't and Liebel scientists. And this tetrahedral structure is the base of the stereochemistry. It is the base of the stereochemistry. Carbon form tetrahedron, regular tetrahedron structure discovered by the Van 't and Liebel scientist. And this tetrahedron structure, ये जो tetrahedron structure है वो stereochemistry का base है. After this, stereochemists find out by the basis of the tetrahedral structure. For this discovery, Van 't and Liebel get the first Nobel Prize in chemistry. First Nobel Prize in chemistry. He awarded by the first Nobel Prize in 1901 for the chemistry. So first Nobel Prize goes to Van 't and Liebel. So Van 't is called the father of organic chemistry. Who is the father of organic chemistry? Father of organic chemistry. Who is the father of organic chemistry? Van 't and Liebel. He got the first prize in chemistry, Nobel Prize in chemistry. So he is called the father of the organic chemistry. Clear? Are you getting my point? The carbon is tetravalent and tetrahedron structure find out by the Van 't and Liebel scientist, and he got the 1901 the first Nobel Prize in chemistry. So he is the father of the organic chemistry. Clear? Now next point. The next character of the carbon is what is the next character? Catenation power. Write down the next point. Catenation. Catenation property of carbon. This is called the unique property. This is unique property of the carbon. What is the meaning of catenation? Catenation का meaning क्या है? Catenation means self linking. So self linking present in carbon. So we already learned about the carbon chain. So self linking in carbon. It form open chain, it form cyclic chain, ring chain. So these are all the carbon linking. So self linking is called the catenation power. Now other element which have self linking, silicon. Silicon also have self linking. So what is the order of self linking? Carbon, silicon, germanium, tin and lead. So decreasing power of self linking. So highest power in self linking is between the carbon-carbon. So carbon-carbon bond is very strong as compared to silicon-silicon. Clear? So carbon chain is present, carbon's ring is present in organic compound. So those compound contain carbon and hydrogen are called organic compound, and these are hydrocarbons. So clear? So what is the point? Catenation. So carbon have unique property is the catenation. Now next heading. So write down the next heading, hybridization. What is hybridization? This topic is similar in inorganic and organic. Hybridization. So hybridization not a theory, this is the phenomena. Phenomena means एक परिघटना, एक थ्योरी नहीं है, ये एक परिघटना है, अपने आप इसकी डिस्कवरी हुई थी. तो हाइब्रिडाइजेशन इज द मिक्सिंग ऑफ orbitals, mixing of orbitals which may be empty, which may be half filled, partially filled. So mixing of orbitals and form hybrid orbitals. तो हाइब्रिडाइजेशन की डिस्कवरी क्यों हुई? लेट्स सी. तो इट इज कॉल्ड हाइब्रिड ऑर्बिटल. एंड हाइब्रिड ऑर्बिटल, ये जो हाइब्रिड ऑर्बिटल बोलते हैं वो कैसे होते हैं? डायरेक्शनल, वो डायरेक्शनल. सो दे फॉर्म द स्ट्रॉन्ग बॉन्ड. क्लियर? हाइब्रिड ऑर्बिटल्स आर डायरेक्शनल इन नेचर and they form the strong bond. So hybridization की डिस्कवरी क्यों हुई थी? Let's see. Take an example of carbon. We take an example of carbon. Carbon according to 1s2, 2s2, 2p2. Okay. This electronic configuration for ground state. ये जो इलेक्ट्रॉनिक कॉन्फ़िगरेशन है वो किसके लिए है? ग्राउंड स्टेट के लिए. Now write down the electrons. In s orbital there is 2 electron, you can see. In p orbital there is 1, 2, px, pz, py, all are degenerate. ये हम एक साथ ब्लॉक क्यों बनाते हैं? These are degenerate. Degenerate means जिनकी एनर्जी सेम होती है. तो 1, 2, 3 those have same energy. Okay, तो this is called the degenerate energy level. इनको हम क्या कहते हैं? Degenerate. What is the meaning of degenerate? Those have same energy. So we have to fill one electron in all degenerate energy level. Then pairing is start. Pairing हम बाद में करते हैं, पहले एक इलेक्ट्रॉन यहाँ फिल करते हैं. Clear? Now you can see there is only 2 unpaired electron. It means carbon can form only 2 bond. कार्बन को कितने बॉन्ड बनाने चाहिए? अकॉर्डिंग टू ग्राउंड स्टेट कॉन्फ़िगरेशन 2 बॉन्ड, बिकॉज देयर इज 2 वैलेंस इलेक्ट्रॉन. बट कार्बन कैन फॉर्म 4 बॉन्ड. तो कार्बन 4 बॉन्ड कैसे बनाएगा? लेट्स सी. एट द एक्साइटेड स्टेट यू कैन सी इलेक्ट्रॉन एक्साइटेड होकर कहाँ चला गया भाई? p ऑर्बिटल में. 1, 2, 3. नाउ हाउ मेनी इलेक्ट्रॉन्स हियर? 1, 2, 3, 4 electrons. It means there is 4 electrons and carbon can form 4 bond. So hybridization की डिस्कवरी इसलिए हुई थी कि कार्बन इस एक्साइटेड स्टेट में 4 बॉन्ड बनाता है एंड 4 इलेक्ट्रॉन की शेयरिंग करता है. सो क्लियर व्हाट इज द हाइब्रिडाइजेशन? नाउ वी आर टेकिंग एन एग्जांपल. फर्स्ट एग्जांपल एल्केन. राइट डाउन द फर्स्ट एग्जांपल ऑफ hybridization is alkane. First example, alkanes. Now we are taking an example of alkane, CH4. Alkane is hydrocarbon its general formula is CnH2n plus 2. So like CH4. So in hybridization, in alkane there is sp3 hybridization. कैसे कैलकुलेट करेंगे? बहुत सिंपल वे है. हाउ टू कैलकुलेट द हाइब्रिडाइजेशन इन एनी कार्बन एटम. किसी भी कार्बन एटम का हम हाइब्रिडाइजेशन कैलकुलेट कर सकते हैं. कैलकुलेट काउंट द सिग्मा बॉन्ड. हाउ मेनी सिग्मा बॉन्ड प्रेजेंट हियर? 1 2 3 4. तो 4 सिग्मा बॉन्ड. तो इट मीन्स हाइब्रिडाइजेशन इज sp3. लाइक ethane. Ethane you can see. This is ethane. Hydrogen, 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 hydrogen. You can satisfied with hydrogen. हमेशा सिंगल बॉन्ड को हम किससे सेटिस्फाइड करते हैं? हाइड्रोजन से सेटिस्फाइड करते हैं. तो फर्स्ट बॉन्ड इज ऑलवेज सिग्मा. फर्स्ट बॉन्ड हमेशा बनता है जो एक्सियल ओवरलैपिंग से बनता है, हेड ऑन ओवरलैपिंग से बनता है. अभी हम पढ़ेंगे इसे. इसको हम क्या कहते हैं? सिग्मा बॉन्ड. It is called the sigma bond. All are sigma bond. So now calculate the hybridization of center atom. Hybridization always center atom का calculate किया जाता है. Center atom is carbon. Here again it is carbon. This is the example of ethane, alkane. So in both carbon sp3 hybridization. So how to calculate? You have to count only sigma bond. So 1, 2, 3 and 4. So its hybridization is sp3. Now let's see how to form methane sp3 hybridization. You can take example alkane and hybridization sp3. sp3 means one s orbital, mixing of one s orbital, one s orbital and mixing of P3. P3 means Px. You can write like this: Px, Py, and above the plane Pz. Pz, Py, and Px. Clear? So 1, 2, 3. So how many total? 4 hybrid orbitals are formed. How many hybrid orbitals? 4 hybrid orbitals. So hybrid orbitals how many form? 4. Why? एक s और 3p. 1s और 3p. Total count 4 and 4 hybrid orbitals are formed. So how to form 4 hybrid orbital? Let's see. Carbon. Okay. In ground state 1s2, 2s2, 2p2. In excited state, this is the ground state. You can write in excited state 1s2, excited state 2s1, okay, and 2p3. So how to write? 1s orbital and in 2p 1, 2 and 3. Clear? So half filled orbital are mixed together, 1s and 3p orbital. So now mixing, there is mixing of 1p orbital and 3p orbital. They form the 4 sp3 hybrid orbital. They form the 4 sp3 hybrid orbital. You can see 1, 2, 3, 4. तो you have to write like this. इस तरह आपको लिखना है 1, 2, 3. तो 1 electron, all are same energy level. sp3 hybrid orbital. So how many sp3 hybrid orbital? 4 sp3 hybrid orbital. Now you can write sp3 hybridization like flower like structure, tetrahedral structure. 1, 2, 3 and 1 below the plane. 1, 2, 3 and towards me. So 1 log, 2 log, and for this 3 log and 1 is above the plane. तो ये जो हमने स्मॉल लॉब बनाई है, इट्स नॉट पार्टिसिपेट इन बॉन्ड ओवरलैपिंग. लॉब आप इस तरह बनाते हैं, पी ऑर्बिटल इस तरह लॉब बनती है पी ऑर्बिटल की. एस ऑर्बिटल कैसा होता है, सिमेट्रिक होता है, स्फेरिकल होता है. ठीक है, तो पी ऑर्बिटल में हम इस तरह लॉब बनाते हैं, प्लस माइनस ये वेव फंक्शन को डिनोट करते हैं, बॉन्डिंग एंड एंटी बॉन्डिंग वेव फंक्शन. तो प्लस एंड माइनस. जो लॉब ओवरलैपिंग में पार्टिसिपेट करती है उसे हम थोड़ा सा साइज में लार्ज बनाते हैं, और जो पार्टिसिपेट नहीं करती उसे हम स्मॉल बनाते हैं, बिकॉज और इलेक्ट्रॉन डेंसिटी कलेक्ट हियर. सारी इलेक्ट्रॉन डेंसिटी आपकी लॉब में सामने आ जाती है. तो दिस इज sp3 हाइब्रिड ऑर्बिटल. ठीक है, ये आपका sp3 हाइब्रिड ऑर्बिटल हो गया. दिस इज द कार्बन. नाउ हाइड्रोजन. हाइड्रोजन का कॉन्फ़िगरेशन आप बता सकते हैं. व्हाट इज द हाइड्रोजन? 1s1. एटॉमिक नंबर इज 1. 1 इलेक्ट्रॉन हाइड्रोजन में है. 1 इलेक्ट्रॉन यहां से शेयरिंग हो गई, 1 इलेक्ट्रॉन यहां से, 1 इलेक्ट्रॉन 1 इलेक्ट्रॉन. तो दिस इज हाइड्रोजन. दिस इज कॉल्ड द ओवरलैपिंग. हियर अगेन दिस इज हाइड्रोजन. हियर अगेन दिस इज कॉल्ड द हाइड्रोजन, and here this is called the hydrogen. So this is called the tetrahedral structure of methane. This is called the tetrahedral structure of methane. Now you can make for this type of structure of ethane. आप इसी स्ट्रक्चर से इथेन भी बना सकते हैं. You can see like in ethane carbon carbon bond is present. Hydrogen, 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 hydrogen and hydrogen. This is called ethane. The bond length between carbon carbon bond length in ethane is 154 picometer. So you have to learn pico means 10 to power minus 12. 1 pico equal to 10 to power minus 12 meter. So 1 picometer. तो द मीनिंग ऑफ 1 पिकोमीटर मीन्स 10 टू पावर माइनस 12. अब आपको कार्बन कार्बन की स्ट्रक्चर ऐसे बनानी है. एल्केन में कैसे बनाओगे? सेम लाइक 1 2 3. 3 सेम होगा एंड 1 p ऑर्बिटल ओवरलैपिंग विद 1 sp3 हाइब्रिड ऑर्बिटल overlapping with another sp3 hybrid orbital. This is sp3 and this is s. It is sp3 hybrid orbital, sp3 and sp3 hybrid orbitals. So now you can form like this 1, okay, 2, 3 and 4. There is now again you can write 1 overlapping, ठीक है, and now hydrogen here, hydrogen. This is the orbital diagram of alkane. Carbon carbon overlapping, this is called sigma bond. All are sigma bond. Here is all sigma bond. Hydrogen here again, hydrogen overlapping with hydrogen, overlapping with hydrogen, hydrogen. So clear how to form the molecular orbital diagram of alkane. This is methane and this is ethane. The condensed formula is C2H6. Now it's clear. Next example, sp2 hybridization. It means alkene. Next example, sp2 hybridization of alkene. So next hybridization you can write. Second example, alkenes And let's see how to calculate the hybridization in alkene. C double bond C. We take an example of ethene. Okay. तो नाउ अगेन काउंट सिग्मा बॉन्ड. बहुत इजी है निकालना. कैसे निकालोगे देखो बेटा, ये सिग्मा पाई बॉन्ड, सिग्मा बॉन्ड, सिग्मा बॉन्ड, सिग्मा बॉन्ड, सिग्मा बॉन्ड. क्लियर. तो कैलकुलेट इन ईच कार्बन एटम. तो 1 2 3. 3 मीन्स 1s orbital and 2p orbital. This is called sp2 hybridization. Again write an example. Carbon ground state 1s2 2s2 2p2. in excited state I think लर्न हो गया होगा सबको. क्या करना है, एक्साइटेड स्टेट में 1 इलेक्ट्रॉन जंप कर जाएगा, यहाँ चला जाएगा, बिकॉज द इलेक्ट्रॉन एनर्जी डिफरेंस इज वेरी लो. एक ही क्वांटम नंबर है बेटा, तो एनर्जी डिफरेंस क्या होगी, लो होगी. तो 1s2 देन 2s1. क्लियर. देन 2p3. 3 को आप ऐसे भी लिख सकते हो 2px1 2py1 2pz1. क्लियर. Okay, now let's see 1s orbital and there is 1 2 3 1 2 orbital and एक इलेक्ट्रॉन आपका pz है. pz अनहाइब्रिडाइज्ड. ये कैसा रह जाएगा बेटा, अनहाइब्रिडाइज्ड. ये हो गए हाइब्रिडाइज्ड. मिक्सिंग हो गई. मिक्सिंग के बाद आप कैसे बनाओगे, हाउ टू मेक 1 2 3 sp2 sp2 sp2. 3 hybrid orbital and all contain 1 electron and one is pz orbital unhybridized orbital. Clear. Now how to form sp2 स्ट्रक्चर कैसी होती है, 2 और 1 3. 3 मीन्स फैन लाइक स्ट्रक्चर, सीलिंग फैन, जैसे अपना सीलिंग फैन होता है उस तरह की स्ट्रक्चर होती है sp2. ट्राइएंगुलर शेप. दिस इज द ट्राइएंगुलर shape. So clear sp2. Now how to form the alkene. Take an example of alkene. So 1 sp2 overlapping. 1 2 3 and this is the log. Hydrogen overlapping here. Here hydrogen overlapping. They form sigma bond. Clear. And it's overlap with another carbon and again fan like structure you have to form. This is the structure. Okay. Carbon overlapping here. Carbon overlapping. sp2 overlapping. sp2 overlapping. Here sp2 and s overlapping. यहाँ कौन सी हो रही बेटा, ये sp2 और ये कौन सा है, s ऑर्बिटल. यहाँ क्या होगा, sp2. यहाँ कौन सी होगी, s ऑर्बिटल फॉर हाइड्रोजन एंड दिस इज sp2 अगेन. ये क्या होगा बेटा, ये भी हमारा हाइड्रोजन है. दिस इज ऑल्सो हाइड्रोजन and s orbital. This is sp2 overlapping. sp2 s overlapping. यहाँ sp2 overlapping हो रही है. Okay, you can see 1 2 and sp2. Now pz orbital, unhybridized pz orbital is also present here. So 1 p orbital which is unhybridized. 1 p orbital, this is sp2 and 1 p orbital you can make here 1 p orbital. How to write 1 p orbital? one p orbital above the plane like this, and one p orbital here, one p orbital here, and one p orbital here. There is overlapping, sidewise overlapping. Clear? This is the pz orbital, pz orbital, pz, and in pz orbital. So in pz orbital there is sidewise overlapping, lateral overlapping, sidewise overlapping, and lateral overlapping, lateral overlapping. It forms the pi bond. And axial overlapping, due to axial overlapping, it's also called the head-on overlapping, HEAD, head-on overlapping. It is also called end-to-end overlapping, end-to-end overlapping. They form the sigma bond. You can see the pi electron density in unhybridized orbital. In pi bond electron density are distributed. Half electron density ऊपर हो गई below the plane and half electron density above the plane. So density is divided into two parts. But in case of axial overlapping, this is axial overlapping, all density collect on the center. So it is the strong bond. So clear why sigma bond is strong and pi bond is weak? Because in pi bond में इलेक्ट्रॉन डेंसिटी आपके टू पार्ट में डिवाइड हो जाती है, अबव द प्लेन, एंड दिस इज लाइक ए बनाना बॉन्ड, above the plane and below the plane. But in sigma bond all electron density are arranged on the center, so it is strong. So clear how to form the pi bond? Now this is called the sp2 hybridization. Again, next example, write down these points. Next we will discuss third point. Third example, alkynes. Write down the third examples, alkynes. Alkynes. तो अगर आपको एल्कीन समझ में आ गया तो एल्काइन आप कैलकुलेट कर सकते हैं. हाइब्रिडाइजेशन कैसे कैलकुलेट करना है देखो. लेट्स सी वी टेक एन एग्जांपल, एसिटिलीन. दिस इज एसिटिलीन. जनरल फॉर्मूला ऑफ एल्काइन CnH2n -2. फॉर एल्कीन जनरल फॉर्मूला फॉर एल्कीन इज CnH2n. दिस इज द एल्कीन. क्लियर? Now next example, acetylene. तो sigma bond, pi bond. So how many sigma and pi bond in each carbon atom? Two sigma bond. So hybridization is sp. sp कैसे बनाते हो बेटा? Linear. This is sp hybridization. Linear. 180 degree. In sp2, 120 degree. In sp3, 109.28 minute. These are the angle. So you have to draw like this, 180 degree. So carbon, again write down the ground state. Process is similar. We already learned 1s2, 2s2, 2p2. What is the excited state? 1s2, 2s1, 2p3. Write down the excited state 1 and 1. समझ में आ रहा है सभी को? Are you getting my point? Hybridization is sp. तो 1s orbital mixing and 1p orbital. So 1s orbital, 1p orbital. How many hybrid orbital form? 2sp hybrid orbital which contain 1 electron. Okay, 2sp hybrid orbitals are formed. Now how many unhybridized orbitals here, 2 orbital pz and py. So this is hybrid orbital and these are unhybridized orbitals. Unhybridized orbitals. Clear? Hybrid orbital, unhybridized orbitals. Now, then how to form the acetylene? Now, molecular diagram of the acetylene, how to form? Write down these steps. There is 2 sp hybrid orbit, 1 sp hybrid orbital form S overlapping of hydrogen and form sigma bond, and 1 sp hybrid orbital form sigma bond, and p orbital, there is 2 p orbital. By sidewise overlapping they form 2 pi bond. So now draw the structure of acetylene. So how to draw the structure of acetylene? This is very simple. Again you can see 1 hybrid orbital, there is hydrogen, this is the overlapping, okay, this carbon and another carbon, there is overlapping like this. This is hydrogen, S, Sp2, Sp, this is Sp overlapping. Clear? यहाँ तक समझ में आ गया? Same as it is. Now 2p orbitals also present here. How to write 2p orbitals? This is 1p orbital, 1p orbitals. This is py. Okay. Here is again py orbital. It contains plus and minus log, plus and minus always. So there is sidewise overlapping. तो 1 pi bond is formed in another pz orbital. अभी एक और हाइब्रिड ऑर्बिटल है आपके पास pz, उसे आप कैसे बनाओगे? इस तरह डॉट डॉट लाइन. हाउ टू फॉर्म? डॉट डॉट लाइन से आप उसे डॉटेड लाइन से अबव द प्लेन. दिस इज pz. नाउ अगेन अबव द प्लेन, हियर अगेन बिलो द प्लेन. तो दिस इज pz ऑर्बिटल. ये आपका कौन सा है बेटा? pz ऑर्बिटल. ओके. तो अब आपकी ओवरलैपिंग किसमें होगी? लेट्स सी. दिस इज द pz ऑर्बिटल. फोकस हियर. दिस इज द pz ऑर्बिटल. हियर this orbital and this orbital. This is the pz overlapping. Now pi bond is formed like this. Now it's clear how to form alkane, alkene and alkyne in this method. Let's see. Now write down these points. Next point, effect of hybridization. What is the effect of hybridization? Effect of hybridization. Sp3, Sp2 and Sp. What is the effect of hybridization? First, bond length order, carbon carbon, single bond, double bond length and triple bond. So what is the bond length? 154 picometer, 134 picometer and 120 picometer. Where bond length, single bond, this is sigma bond, this is double bond, sigma and pi, this is triple bond, unsaturation is present here. So bond length hybridization sp3, hybridization sp2 and sp. So bond length affected by the hybridization. When here is S character is 50%, 33% and 70. There is 50%, there is 33% and there is 75% P character. So bond length is this. Second, bond strength. Bond strength depends on bond dissociation, bond dissociation enthalpy. Bond dissociation enthalpy means amount of energy to require the bond break. ट्रिपल बॉन्ड ब्रेक करने के लिए हायर एनर्जी की रिक्वायरमेंट होगी, डबल बॉन्ड इससे कम, देन सिंगल बॉन्ड वेरी लो. सिग्मा बॉन्ड इज स्ट्रॉन्ग बट देयर इज पाई बॉन्ड ऑल्सो प्रेजेंट. तो पाई बॉन्ड ब्रेक करने के लिए कुछ एनर्जी की रिक्वायरमेंट तो होगी. सो बॉन्ड स्ट्रेंथ, द ऑर्डर ऑफ बॉन्ड स्ट्रेंथ इज C ट्रिपल बॉन्ड C, C डबल बॉन्ड C and C single bond C. So what is the bond strength? 433 kilojoule mole inverse and its bond strength is 383 kilojoule per mole and for carbon-carbon bond length is 348 kilojoule per mole. So which is strong bond? Alkyne. Triple bond is more strong bond. More bond strength is more strong because bond dissociation enthalpy is higher for triple bond. Bond length, bond strength, it means bond dissociation enthalpy, and it's clear. So now third point is electronegativity. So what is the third point? Electronegativity increase when S character increase. Third point, electronegativity means attraction of electron towards itself. Negativity. So what is the meaning of electronegativity? बॉन्डेड इलेक्ट्रॉनों को अपनी तरफ अट्रैक्ट करना, जैसे HX में X की इलेक्ट्रोनेगेटिविटी हाईएस्ट होती है, तो ये बॉन्डेड इलेक्ट्रॉनों को अपनी तरफ अट्रैक्ट करता है. इट गेट द पॉजिटिव चार्ज एंड इट गेट द नेगेटिव चार्ज. तो इलेक्ट्रोनेगेटिविटी इंक्रीज व्हेन S character increase. Sp, Sp2 and Sp3. So electronegativity also affected by the hybridization of the carbon atom. So it's clear these points affected by the hybridization. So now it's enough for today's class. Have a nice day. Thank you all of you.